Hello everybody, my name is Griffith Hughes, and my goal with this video is to get through 3 topics. Number 1, a quick review of inverse functions. Number 2, what is the proof for the derivative of an inverse function? And number 3, how do we solve problems involving the inverse derivative? So, what is an inverse function? Let's imagine that we have some function f of x. As long as f of x is a one-to-one function, which means that every x value corresponds to only one y value, its inverse will also be a function. So I'm just going to draw the inverse, or what it might look like real quick as a dotted line. Something like that. Another easy way to test if it is one-to-one is if it passes both the vertical and horizontal line tests. To find the inverse function, you merely swap x and y and solve for the new function. Thus, the inverse of f of x equals x minus 4 is x plus 4, and the inverse of f of 5 equals 1 is f inverse of 1 equals 5. When graphing inverse functions alongside the original function, you will find that the inverse function is a reflection of the line y equals x. Since this is all stuff we should know, I'm now going to move on to the proof for the derivative of an inverse function. Based on our quick review of inverse functions, we can combine the original and the inverse functions into one equation to get, drumroll please, f of f inverse of x equals x. And if you don't believe me, you can test it using any point like 3, 4, f inverse of 4 equals 3 and f of 3 equals 4. Bam. And this is very useful for proving the derivative of an inverse function. If we set g of x equal to the inverse function of x, the equation now becomes f of g of x equals x. Using our knowledge of the chain rule, we can now find the derivative of the inverse function by solving for g prime of x. Going through this, we're going to get f prime of g of x times g prime of x equals 1. Therefore, g prime of x equals 1 over f prime of g of x. Once we substitute the inverse function back into the equation, we find that the derivative of an inverse function is equal to 1 over f prime of f inverse of x. And we can now begin to solve some problems. Most of the problems you will run up against in this class will be in the form of find the derivative of the inverse of f at the point x equals a. Or you might be given a point and a slope and asked to find the derivative of the inverse function at that point. We are going to find the slope of the tangent line to the inverse function at the given point. If we are given f of x equals x cubed plus 2x minus 8 and the point 4, 2 on the inverse function, we must first start by finding the derivative of the equation, which is f prime of x equals 3x squared plus 2. Since the point that we were given is on the inverse equation, we know that f inverse of 4 is 2. And we can substitute 2 into our equation for the derivative of f of x based on the proof that we just did, which was 1 over f prime of f inverse of x. Therefore, we are going to get 1 over f prime of 2, which equals 1 over 14 once we plug 2 back into the derivative that we found. Not that hard, right? Let's do a harder one. Given f of x equals 7x cubed plus natural log of x cubed and x equals 7, find the tangent line of the derivative of the inverse function. First, we must set f inverse equal to 7 and solve for y. You can either use logic or the solve function on your calculator. On the TI Inspire non-CAS, type nsolve, begin parentheses, the function, which is 7 equals 7y cubed plus natural log of y cubed, comma, y, and it will spit out 1, which you can get by reasoning through it. The natural log of 1 is 0, 7 times 1 is 7, 7 plus 0 is 7, 7 equals 7, woo, you did it. We end up getting 1 as our answer either way. Now, we must find the derivative of the function and then plug 1 into it to find the slope of our line. So we go f prime of x equals 21x squared plus 3 natural log of x squared all over x. Plugging in 1, we get 21 plus natural log of 1 is 0, 0, and so the slope of our tangent line of the derivative of the inverse function is 21. Now, since we know that the point 7, 1 lies on the inverse function and we're solving for it at 7, we can plug everything into the point slope formula. We get y minus 1 equals 21 times x minus 7. Yay! We did it! Nice job. Thanks for watching. I hope this was helpful. Yay.